Okay, so the title of the talk tonight is How I Built My Code Editor in Ruby. So let's get started with this question right away. How did I build my code editor in Ruby? So yes, I used Ruby as a programming language using JRuby. I applied object-oriented design with abstractions like file and directory. I applied architectural patterns like MVC and MVP. I applied design patterns like command, pattern, composite, adapter, and observer. I used domain-specific languages like the Glimmer GUI DSL. I decomposed software modules, meaning components or custom widgets, when building GUI. I reused Ruby gems, Ruby libraries like Glimmer DSL, SWT, File Watcher, and Clipboard. And that's all, folks. I gave you the answer. I'll go home now. Just kidding. That was just a preview of the talk. Hang on for more. Okay, so about myself, I have a Bachelor of Science in Computer Science from McGill University, Montreal, a Master of Science in Software Engineering from DePaul University, Chicago. Like Mathieu mentioned, I've spoken at a number of conferences. I've recently won the Fukuoka Ruby 2022 Special Award by Mats, the creator of Ruby. And I work as a senior full-stack developer at Lookup. So why build a code editor in Ruby? So let's start with the why. The first reason is Ruby is a great language. It's object-oriented. It's dynamically typed. It's inspired by Lisp, Smalltalk, Perl, Python, and Basic. So that means Smalltalk is one of the first languages that demonstrated a very high level of object-oriented programming. So Ruby has some of the best style of object-oriented programming in the world. Lisp demonstrated how to build embedded DSLs, like embedded languages within Lisp, in order to become a lot more productive at building the business apps. Ruby has that. Perl has a lot of good terminal or command line support, especially for opening files and running commands and stuff like that, so Ruby has that. Python has nice syntax that Ruby inherits, some of, and Basic also is known for being very approachable by non-programmers, so Ruby has that as well. Ruby, as a result, supports metaprogramming and embedded DSLs, like I mentioned, just like Lisp. So it's very expressive, it's highly expressive, and it gives us very maintainable code. So that means it's very productive, like Rails. Rails is famous for being one of the most productive frameworks for web development in all programming languages nowadays. A second reason is I'm a senior software engineer. I have about 19 years of software engineering experience. I've been programming since I was a kid, even before, I have 19 years of professional experience, but I've been programming since I was a child, so I have over 30, 40, maybe almost, not 40, but over 30 years of experience in programming. So why would I not build my own code editor? I'm proficient in requirements engineering, meaning how to take requirements and turn them into analysis and design that results in software. I'm proficient in object-oriented programming. I'm proficient in architectural patterns, design patterns, domain-specific languages, writing highly maintainable code, automated testing. So one day I woke up and I'm like, why am I using somebody else's editor? Why not build my own editor? And the other thing that bothered me was, why are all editors not written in Ruby? Ruby is one of the best programming languages in the world. Code editors should be written in Ruby too. So that's how Gladiator was born. It was an open source project that was born out of the idea of exploring Ruby in order to build my own code editor. So let's start by doing a demo of Gladiator. So I'm gonna get out of the presentation mode and launch it. This is the icon of Gladiator. So it just gives me this button that says open project, and then I can select a project like Gladiator itself. There it is. So basically it has a syntax highlighting for over 30 programming languages. And what you're seeing here is Ruby code, and this is the code of Gladiator itself. It's got find and replace support, so I mean I can use any keyword and look for occurrences of it, like that, for example. And I can do replace. I can do it, make it case sensitive or not. I can look up files, so if I want to look up a model, I type model and it gives me all the models, and then I can navigate to this model, the directory model. I have a file tree navigation on the left side over here. It's a file tree explorer that lets me navigate all the elements of the project. So it's got binary scripts for launching the app. It's got configuration, icons, images. Most of the logic for this library is under lib, and it's got views, models, a launcher script, and the main entry point of the project. What are some other features? Oh yeah, one cool feature is I can open like a scratch pad, and for example, type in a script here and say, let's just say, text hello world, label hello world, and I can run it. Unfortunately, this didn't run. That's what happens at demos. Yeah, so I'm supposed to be able to run a Ruby script. I don't know why it's not running, but we'll leave that for another time. But let me open another project. So I can open multiple projects. And this is a Ruby script. Let me try to run this one. Okay, cool. This one ran. So this is another app. It's just a demo app of how to use a syntax highlighted text editor. It's called Hello Code Text, and I just opened it. And the code of the app is here. This is the app that I just opened. So let's get back to the main project. Let's close this. Yeah, I mean, I can right-click a file here and delete it, refresh the tree, create a new directory, a new file. I can do copy-paste, and then we have a menu on top, open scratchpad, open project, standard edit menu with the undo, redo, copy, cut, paste. Oh yeah, this is cool actually, split pane, so I can split the pane vertically or horizontally. Actually, I can also use the keyboard shortcut, so I can do this. This is good because then I can open tests, for example, like specs. So let's just open a spec on this side. That way I can put the spec on one side, and there it is. The file model is on the left side, and the file spec is on the right side. So it helps me be more productive. But there are many other shortcuts, like I can, I just showed you this. I can minimize the coding area to basically hide all of those extraneous panes. So, and then I can even focus on one of the two sides. So I just focused on the test side. And I can also close it and come back to this side and come back to this, or I can just open the file, find and replace alone. And I can use the mouse to do this or that. So it's very basic functionality for what a code editor is. I think I pretty much covered everything. I mean, you guys saw tabs, so I have multiple tabs for opening multiple files. When I'm navigating a file, I get some sort of analytics here about, like, I mean, it's not exactly analytics, more about what is the caret position, what is the line number, etc. I can jump to a line, like with 100 or 89, it jumps there. So it's very basic coding functionality. I built this in the year 2020, sorry. I've been using this for about 3 years now. as the main editor for all of my work, open source or closed source. So it's good enough for all my personal needs. And I'll talk more about how I got into that. Any questions before I move on?
What library do you use to render the UI?
I'll get to that.
Okay.
I'll answer that in a bit. Any other questions?
Is it cross OS if I'm on Linux?
Yes, this runs on Windows too, and it runs on Linux with some hiccups. And so it's designed primarily for Mac, because that's where I use it the most, but I've been able to use it on Windows and Linux as well.
That's pretty cool. That's because of Glimmer?
Yes.
Nice.
So, okay, so what is the Gladiator software architecture? Before we dig into the code and the design and all of that, what is the general architecture? So it's a GUI app. It's by GUI I mean graphical user interface. So graphical user interface apps usually in general use the MVC pattern, which came from Smalltalk, the Smalltalk programming language, because it provides a very clean separation of responsibilities. So usually in a GUI app, you have a screen that gives you a sort of a user interface with items on it. And then you interact with the screen using control devices like the mouse and the keyboard. So that's the controller part of the MVC. So you have the view, which gives you the screen. You have the controller, which lets you control the app with the keyboard and mouse. And then the model is basically the business model behind the app that you're building. It's basically what are the concepts of the app? So I mean, in Gladiator, obviously some of the concepts that are very obvious are we have a text editor, we have text editor tabs, we have a file explorer tree, etc., etc. I'm going to get into that in a moment. I'm also applying something called the MVP pattern, which is a variation on MVC that makes the controller a presenter. So the controller is not only about controlling, making changes through the keyboard and mouse to the view, into the model, that are recorded in the model, but also it's about observing the model for changes and making them get reflected in the view automatically. And that's done using something called data binding, or bidirectional data binding. Data binding lets you basically declaratively bind certain elements of the view into certain properties on the models. I'll show you code examples of that. Thirdly, the app is decomposed into software modules, aka components, aka custom widgets. So Gladiator itself is a component, meaning if I want, I can embed the entirety of Gladiator into another app, and I can bring it up when needed just to edit some code. But also, it's decomposed into smaller components like text editor, file explorer tree, file lookup list, the file edit menu, the Gladiator menu bar, and the progress shell. One thing I want to note is these are the general architectural concepts behind building Gladiator, but it's not in any way, shape, or form completely, perfectly, and cleanly adhering to them. The code, it's not a completely clean MVC, but that is the general concept that I built Gladiator around. As far as the software development process, what happened is I basically made this challenge with myself of not using any editor to build Gladiator except what comes built into the operating system. And on the Mac or Linux in the terminal, I have Vim. So I only used Vim to build Gladiator initially. Secondly, I started very, very small and built features incrementally. And I started with the smallest thing possible that would enable me to upgrade myself from Vim to something better. So that's what the third step is. And then I started eating my own dog food and using Gladiator to build more Gladiator features. So initially I had nothing but the text editor. I didn't even have tabs. I had just the text editor, and I might have had the file tree. That's it. Eventually I added a file lookup list, and then I added tab support, and then I added split pane, etc., etc. And that's how I'm continuing development on this project for 3 years. I mean, I touch it once every few months. I'm not working on it every day or anything, except in the beginning. I might have worked on it every day for a month or two in the beginning. But now I touch it every few months, and whenever I need a new feature, I upgrade Gladiator with a new feature. As far as the software development process, I use something called the Glimmer process, which I came up with when I built another open source library called Glimmer. It's simply made up of 7 guidelines to pick and choose as necessary. It's not very dogmatic. You can rule out some guidelines if you want, or not apply everything. And you don't have to follow an order. It's just a summary of all my learnings from my software engineering work, as well as my master's in software engineering. So, I mean, there's a requirements gathering phase usually in any app, meaning writing down a list of tasks or features that you want. It doesn't have to be complete, but you need to have something to start with. And usually you do prioritization on this list. You need a sort of a general architecture and software design, an initial release plan, meaning what do you want to release for version 0.0.1? And then what do I want to release for the MVP, the very first beta alpha release, and then the very first beta release, etc. So you need some sort of a release plan. You need small releases. So no release took me more than 2 weeks per release. And to be honest, in general, they were usually 2 days maybe per release, maybe even less. Usability testing, I am my own user in this case, so I can tell myself what I don't like and what I like. And automated tests. I did not write a lot of automated tests. This project was more, I'm using it every day, so that is that test. I don't need an automated test, but this is a good example of why here I don't recommend to be dogmatic about any of those guidelines. But I do have a few automated tests. There were a few parts that were a bit buggy that I ended up resolving the bugs with by running tests first for them. Any questions before I move on?
Yeah, question. Did you ever open it up to outside testers?
I did, yeah. I have a few users for the project, and they've reported some bugs to me in the past, mostly to do with Windows, because I don't use it on Windows much.
Maybe not just bugs, but maybe also potential features or improvements or enhancements. Well, I'm hoping we'll have a lot more users after today. Yeah.
And refactoring, of course, that's a very important point. Often I write a feature in a very big blob of code, but then a month or two later, when I try to add more features on top of that, it becomes very difficult, so I end up refactoring. And however, I follow this rule of I only refactor as much as needed to facilitate future work. I won't try to immediately refactor it into the perfect structure, so I refactor as needed only. But that's been always important, refactoring. I refactor almost every release. So let's start digging into the implementation of Gladiator features. So first, let's get into the file tree navigation. So I have the code over here. The file tree navigation is basically this part on the bottom left. It's simply a tree structure of the directories of the project that I opened. So in this case, the project that I opened shows up over here, the absolute path of it. It's basically, some absolute path, code, and then glimmer-cs-gladiator, which is the official name of this project. So how did I build this part? So this part has been decomposed into its own component eventually, and right now it's called the File Explorer tree. So we can just look at the code of File Explorer tree to know how that is implemented. So I'm using Glimmer as the user interface library. Glimmer DSL for SWT lets you use the SWT library, which is the same library that Eclipse IDE is built with. So I'm using the same technology that was used to build the Eclipse IDE in order to build this editor. And that technology is written in Java. So in order to use Java libraries from Ruby, you have to use JRuby instead of CRuby. So I'm using JRuby as well. So that's how I've been able to leverage SWT. And I've leveraged it using the Glimmer DSL for it, which gives you a Ruby way of dealing with SWT as opposed to the Java way. The Ruby way gives you a DSL that maps to the structure of the graphical user interface. And usually whenever you build a component, you need to extend, if you're building a custom widget, custom component, you need to include this Glimmer : UI : custom widget module or mixin. After that, you declare the body inside this body method. Not method, it's actually a body sort of structure. So body lets you build the graphical user interface as a hierarchical structure. So think of this as the Ruby version of HTML. HTML lets you open a body and nest in it divs, and then within the divs you can nest paragraphs, and within the paragraphs you can nest labels if you want, and input text fields, etc. This is the same thing done in Ruby using a DSL. So here, the rules of Ruby style guides change a bit. You try to think of it declaratively, not imperatively. So when you're writing imperative code in Ruby and you have a method that you're invoking, when you pass it a block, you usually say do end, and because you're being imperative, you're saying, okay, this is the method, print, and then do, and within the do, maybe you want to do extra work before printing some text, and then end. That's because you're writing imperative code. Here, I'm writing declarative code, and I'm taking advantage of the fact that in Ruby I can write DSLs. And DSLs is basically a language embedded within Ruby that lets me write graphical user interface code. So I have a body. Within the body of this component, the first thing that appears is a tree. And this is the tree that you guys are seeing over here. And then within the tree, so whenever you open so usually, I mean, just to give you an example, in HTML, I would have done it like this. I would have done body, and then within that, I would have done, there was no tree component in HTML, but if there were, that's what it would have been. And that's how I would have done it. The same exact code in Ruby, you would do it like this. You would say this, you open a block and you close it, and then you say tree, open a block, close it. It's a lot more, it's drier, because I don't have to have a closing tag. You just use a curly brace to close it. And then within the tree, you can declare properties of the tree. So let's get back to the code. Whoops.
Amy, do you have a way to zoom in just a little bit for the folks at the back?
Oh yeah, let me zoom in, yes.
Yeah, thank
I'll
you.
zoom in. Okay, so kill those. Okay, so, boom.
Thank you.
Is that better?
Yeah, much better.
Cool. Okay, so the body is the tree element, and then within the tree, we have the tree items, we have a foreground color, we have some basically declarative stuff about how to support drag and drop from this tree, which I'll get into in a moment. And then we have a menu. So under the tree, we have a menu nested, meaning the menu has open, delete, refresh, rename. So this is basically, if I were to unzoom for a second and zoom back here, this is what happens when I right-click on one of those elements, and you get this menu. It's got open, delete, refresh, etc. So the code structure mirrors the GUI structure, meaning the menu belongs to the tree. So here you nest the menu within. Sorry, I must be looking at a different tab. I'm sorry. Let's go back here. This one. Yeah. So here we have a tree, and we nest the menu within it. And this is very similar to HTML. In HTML, you basically have, for example, a form, and within the form you nest an input field, and the input field belongs to the form. Here's the same way. It's basically, I have a menu that belongs to this tree, and it'll pop up when I right-click on an element of the tree. So the tree items is basically how I'm populating the tree, and this one line is populating the tree using data binding. So all I'm doing is I'm basically binding the items of the tree to the project directory attribute, on self. Here I'm specifying that in order to grab children from that object, you need to invoke the children method. And in order to grab the text, the string that will be displayed for every child, like what is the file name, for example, basically I'm invoking the name method. So by using data binding, I've reduced the work of populating the tree into a single line of Ruby code. That's it, which is unheard of in other languages. In Java, you have to write pages and pages of code to build GUI like that. Like, I'm pretty sure that Eclipse IDE itself has pages and pages of code to do stuff like that. So, because I used to do Java development of GUI in the past. So that's why I love Ruby. I mean, in Ruby, this is a single line of code. It takes care of populating the tree declaratively. Why? Because if you think about it, what is a tree? A tree is simply a hierarchy that begins with a root element and it ends with leaves at the bottom. So how do you data bind a tree? The simplest way of thinking about it is I need a root element, first of all. Second of all, I need to know what method should I invoke on this root element to get the children of that element recursively. And basically the method is children. I ended up having a children method literally on that object. And then on every child, once I grab the child, how am I going to display the text in the tree item for it? Well, I call the name method. So that's all you have to do using data binding declaratively. That's basically all this information that I just stated is here in one line of code. And by the way, tree elements follow the composite pattern in object-oriented programming, meaning every element is a composite of more elements, and every sub-element is a composite of even more sub-elements. So that's called the composite pattern. And they all basically have to extend the same class. So all the items of the tree have the same, superclass, which is a composite sort of superclass. And if I were to dig into the model, so the root object is a project directory. The model is a directory. So if we were to look at the model layer, we have a Glimmer Gladiator directory. And the directory has a number, it basically has a lot of attributes, but one of them is children. And that's the attribute that I configured to be loading the tree in the GUI. It has a selected child as well, because when I open a file like this one, that's the selected child right now. So every composite has to know which child is selected underneath. And there's a lot more information. I'll get into it later, but that's pretty much the gist of what a tree is and how I was able to populate the tree. I basically made a directory here that will populate itself with an initial path, which is the root path of the project. And then from that point on, there is logic on the model that will let you grab the children, and behind the scenes, it'll call the Ruby facilities that will shell into the command line and figure out what files are under that directory, as well as what other subdirectories are under that directory. So that's pretty much it. I mean, the menu items, you got the gist of that too. So there's a menu, it has menu items underneath. Within every menu item, there are properties as well, like what is the text of the menu item. And then there's a listener. So this gets into the observer pattern from MVC. Usually in MVC, well, let's get back to the diagram of MVC. Might be helpful to get into it right now. Actually, let me just jump into it right here. Okay. Usually the view, anything you see on the view is a visual representation of the model data. So the view is usually observing the model for changes, and then it gets updated from model data. That's how MVC, the clean Smalltalk MVC works, the proper one. And then the controller, on the other hand, is observing what the user wants to do with the keyboard and mouse. And when the keyboard and mouse are triggered, it actually will end up calling the model to cause a change. And then since the view is observing that model for changes, it'll get updated indirectly after the user had made a change with the controller. So, so here what I'm trying to say is basically you can configure listeners on menu items to tell which are basically playing the role of controller, following the observer pattern. And this listener, the block of code that's underneath it will get triggered when I click on the menu item. So, I mean, if I click here and I say, let's just say rename, that's more obvious. It'll let me rename the file, for example. So that's because it responded to one of those controller actions that I have configured over here. I probably should rename it back though. Okay. Yeah, so I'll get into a lot more detail later. Let's just jump into a few other components from Gladiator just to, yeah. Let's talk about something else. File lookup by name. So file lookup by name is this part. So how is it built? Again, it's a component. I have a file lookup list component here. It's got a body. And again, just like HTML, except with a much lighter version of HTML. And it's not HTML because it's desktop development, so it's more of a, I call it the Glimmer GUI DSL. It's a DSL for a GUI development. It's called Glimmer. So I'm using the GUI DSL here, the Glimmer GUI DSL, and I have a list in this case. This is a list that will show me files that are looked up using a text control. So here I typed models, so it basically did a search that showed me all file paths that have the word model in them, but I could have typed view, that would have given me everything that has view in its path. And in other IDEs, usually this feature is hidden. You usually have to type a shortcut like Command L or something and it'll pop up. I chose the design of keeping it shown all the time because I thought it might be more user-friendly. I'm being my own usability expert on my own app. That might be just my own opinion. Maybe most people like disagree with me, but it's just an example of, when you're building your own app, you eat your own dog food and you can build the app exactly the way you want.
The project is open source,
Yes,
so I could fork it and make it
absolutely,
my own. So
absolutely.
I agree with your opinion on that.
Thank you. So yeah, so it's a list. It's got a selection that will be, so the list selection attribute will basically data bind. Whenever I select an item in the list, it'll end up storing it on this filtered path attribute on this object, project directory, using data binding. And data binding is usually bidirectional, meaning when I first load the list, whatever is stored on that project directory will show up in the list. But then if I make a selection, it'll store a value back on the model. So that's why it's called bidirectional data binding. It's a bit superfluous to say it because it's intuitive. Usually you want to make a change to the code, and you also want to see changes reflected back to you. So almost always you want to do something bidirectional. And again, it has a few properties: selection, foreground, and then it's got listeners. Listeners always begin with the on keyword. So on mouse up, on key pressed. So on key pressed is basically if with the keyboard, I use the keyboard as a controller, and I click enter, it'll open that file. Like right now I am on that file, but let's just say I pick a different file, this one. See, it took me there. So on mouse up will actually change the selected file on the project directory that is open over here. So basically that one is, if I click on a file, so let's just say I click progress shell, it'll also open a tier. So basically this is happening indirectly using the MVC pattern. That's what makes the code kind of clean. The code is a single line of code. Like this single line of code couldn't have done all the work for figuring out the file path, opening the file contents, and opening up a new text editor and then showing it in a new tab. There's no way that line of code did all of that. Well, that's true, because that line of code isn't doing all of that directly, but it's doing it indirectly. All I'm doing here is I'm updating an attribute on a model and saying this is the new selected file. However, because I'm following MVC, I have code elsewhere that says observe that attribute on this model and do all the work that I just mentioned, which is open the file contents, open a new text editor, load it up, etc. But the code here is so clean. Like if I'm maintaining this code, it's a single line of code. Like I'm not thinking of all the other details at the same time. So that's pretty much that. This is drag and drop. Drag and drop is a bit complicated, but it actually got simplified in more recent versions of Glimmer. Still, this is not that complicated. It's basically saying that if I drag anything from here, set this data for dragging. Basically set the path of the file. That's it. Set it as the event data. And then when I drop the file somewhere else, there's a code elsewhere that's saying if I drop, so let's do drag and drop. So if I drag this text editor and drop it here, it basically split the screen and open a new editor here. So there's another code elsewhere that is waiting for that drop to happen. And it's actually in Gladiator, if I'm not mistaken, or let me double check. It might be in text editor. Oh yeah, these are synced using bidirectional data binding, so that's why they both scroll at the same time. I built it that way. Some people might not like to build it that way. They might want to separate the scrolling, but I actually kept them synced. For me, it's good enough like that. But if I were to dig into this, the text editor has, there it is. There's a drop target declaration here that's saying if I drop something here, grab that data, that was the event data, and then set it as the selected file on the project directory. And again, there's then code elsewhere that is monitoring that selected child path. And as soon as it gets set, it creates the text editor and it opens it. And if it's a drop event, it'll automatically detect that it's a drop event because I'm setting this attribute, drag and drop true, and it'll split the screen for me. Whereas if it was not a drag and drop event, if it was something else, it would have not split the screen. It would have just opened a new tab. So let's move on. So text editor, you already saw with the text editor a little bit. This is the text editor. Basically, it's got a line numbers part, which is you're seeing it here on the left side. And it's a styled text widget, meaning text that could be styled, just like HTML. Think of it as just like HTML, but it's in a desktop app context. I'm data binding a whole bunch of attributes here, and the key one is basically top pixel. Let me see. Wait, I might be pointing at the wrong attribute. Actually, I can just search for it. Pixel. Yep, there it is. Okay, I'm doing it in a different place. Never mind. Load line numbers, text content, and then here I'm basically what you could do with Glimmer is reopen any component later if you want and add more stuff to it, like more properties or more elements within it. So just like how Ruby supports open classes, Glimmer supports open GUI objects, like GUI components. You can always reopen a GUI component and change it. So I'm changing it and basically synchronizing with bidirectional data binding the top pixel value to the top pixel attribute on a model called the file model. And that will synchronize, so basically when I scroll up and down, the top pixel is the distance of the pixel that you're viewing on top here from the beginning of the document. So for example, here the top pixel is, oh yeah, by the way, we're showing it here. So here the top pixel is 402. If I scroll down more, it grows even bigger. Now it's 1463. So that's how I end up syncing the line numbers on the left side with the code on the right side. So basically I have two text areas, two styled text areas, one that is representing the line numbers and one that's representing the code. The code text area is called code text, which is a more advanced version of style text. Style text lets you style a text area any way you want. Code text will automatically infer the styling from the language that you're using. So that's why I specify to it the language. I specify here the language that I'm using. In this case, it's Ruby. It'll actually use the model to figure out what the language is. So based on the file extension, if the file extension is .cr, that's the Crystal programming language. If it's .rb, it's the Ruby programming language. So for example, if I were to open readme.md, that's MD, that's Markdown. So that's a different, you see, like it also has coloring, but it's different. This one's more focusing on Markdown syntax, like building URLs, for example, links. So again, I'm just giving you a very high level overview of this project. I'm not like, this is a very advanced, I would say, presentation, and I'm gonna leave you with the high level overview of how to build your own editor, but then you have to do your own homework afterwards and study Glimmer, and also build your editor piece by piece in very small increments in order to simplify the problem for yourself and successfully build your own editor. So tabs, what are tabs? Basically, tabs always fold under something called a tab folder. So you need a tab folder in order to have tabs in an application. So here I have a tab folder. And if I were to look at where it was assigned, whoops. There we go. This is where it was assigned and built. I built it using this method. And this method is basically, the nice thing about being in Ruby, not HTML, is in HTML, if you want to break small parts of the page into their own page, you can't without using a technology like Rails with ERB and partials. On your own, you can't. You don't have support for that. Actually, the newest HTML is beginning to add support for building HTML components in JavaScript. But still, within HTML, you can't. You need JavaScript for it. Here, the nice thing in Ruby is I can just build a method that has a useful name and then call that method, and within it, I can just build a tab folder and add listeners to it, drag and drop support, etc. Like, because you can also drag a tab if you want to split the screen sometimes. Like, sorry. Yep. So I can drag a tab. Whoops. I guess I have to close that. Okay. There we go. So I can also split the screen by dragging a tab. Yeah. So tabs always start with a tab folder, and then I usually, when you first open the project, it might have no tabs, like 0 tabs. And then I add tabs to it by reopening the content of the tab. So that's why I end up relying on this .content method that I showed you that lets you reopen the content of the tab folder and then add tab items. And then within the tab item, I add the text editor widget. So this text editor component that I showed you earlier, which has the class name text editor, by convention in Glimmer, if you build a class name with this class name, and it includes the custom widget mixin, that will automatically make a text underscore editor undercased method available for you within the Glimmer GUI DSL to invoke that component. And this is how I can use here the text editor keyword. So that means you can build an unlimited number of widgets or components for yourself for your GUI apps in order to build higher and higher abstractions that simplify the way you think of your app. In fact, like I mentioned in the beginning, Gladiator itself is a keyword of those. So that means I can include this entirety of Gladiator in another Glimmer app by using the keyword Gladiator only. That's it. It does everything that we're seeing here, just with one keyword. And that comes from Lisp, by the way. This is one of the great things of why Ruby inherits some features from Lisp, like embedded DSLs. Okay, tabs, find and replace. I think it's simple enough. I don't have to cover it. Keyboard shortcuts. Keyboard shortcuts are basically another form of controller. On text editor, for example, at the bottom, I have a listener that says on verify key. Verify key listener will execute right when I hit a key, but before the key shows up on the screen. So if I'm typing, for example, and I'm typing a character, right when I hit the character, but before it shows up on the screen, the on verify key listener will fire. And here within this listener, I just check what that key is and then I execute a shortcut. So it could be, let me show you some shortcuts. So I can do this, like indent in, indent out. That's command right and left brackets. I can do command up and down. I like that one a lot. Like it lets me move a line up and down very quickly. I used to use this in Eclipse a lot. Eclipse has that feature, so I wanted to add it to my own editor. I can duplicate a line, command D. So all of those are just here, like see, I check, okay, the user clicked command and clicked Z, so that must be undo. And again, like see if I do this, I can hit command Z and that would undo it. So that's undo. So all the shortcuts are basically, I check for every key combination, and whatever that key combination is, I end up firing a command for it. Oh yeah, that's one thing I could cover now. Undo redo support is done using the command pattern. That's the classical way of implementing undo redo usually. So that's why here, for every command that executes like this will fire a command that will say indent in, indent in. Now I have a command class that will actually keep track of the history of all the commands that fired, and that's how I do undo redo. Eventually I can fire an undo command, it'll just go back to the history of all the commands that ran, and it'll go back a command. It'll basically undo the text content value to its older version. So I keep a version of the text content on every command change. One more thing I had to do is, usually commands are, you have for every command, like indent or outdent, you would have a separate class. That would be the clean way of implementing command pattern. The thing is, when I started building the project, I had a file class that was representing all file operations on an open file. And within it, it has methods for every operation. So I have a method that says, let me show you. Prefix new line, remove line, insert new line, indent, I just showed you indent, outdent, etc. I have a method for every one of those operations. I could have refactored this code and moved every method into its own command, but I was trying to save myself time, and I used some of the crazy Ruby metaprogramming features to get around that. In Ruby, every method is considered a lambda. You can convert any method to a lambda, and then a lambda is an object. So that's already kind of like a command. So then what I did is I used the adapter pattern, and I made the command class adapt methods from the file class into commands without making them commands. So that's just one of the cool things about Ruby. Of course, I'd like to, in the future, to refactor file and break all of those into their own classes. That would be a lot cleaner, because this is like right now a giant file. It's like, what, 700 lines of code. So it would be cleaner for me to do real command pattern, but I'm just showing you Ruby is cool. Sometimes lets you cheat and get away without having to do the pattern right away. But in a future refactoring, hopefully I'll handle that. You guys saw split pane, you saw menus, you saw how to run Ruby code. I mean, running Ruby code is the simplest feature. All you have to do is read the contents of the file and eval. That's it. In fact, I bet I have an eval here. No? Maybe I'm wrong. Maybe I did it. How did I do it? Let's see. Maybe I did it a different way. Let me see. Do I have a run here? It would have to be here. Okay, there it is. Run. Oh, never mind. I didn't do eval. See, I write clean code. I don't use eval. I'm just joking, because eval has a very bad reputation in Ruby. I use load instead of eval, which is the next ugliest thing, but I'm just joking. It's not that ugly in this case, because if you have a file and you want to run it as a Ruby file, and I'm already inside Ruby, you can just load it. So that's what I do. I just load it. And oh yeah, and if it's a scratch file, it means it's a temporary file. I create it in a temporary place and then I load it. That's pretty much it. So yeah, I think I pretty much covered everything here. These are 3 esoteric features towards the end that I'm going to cover. Basically, watch the file directory. Yeah, watch the external file directory system for changes. That means that if from outside of Gladiator, I end up creating a file, it will show up over here. So let's hope it works right now. Sometimes that doesn't work, but Gladiator, there it is. Okay, so if I were to touch, let's just say new file, and then I think it showed up. Yeah. There it is, new file. So this is basically, I have I'm using a gem called a file watcher that will watch the file system for changes, and as soon as they happen, it'll reflect them in the tree, the file explorer tree of Gladiator. So that's what that is. I'm just using a gem for it. I bet the code is here, file watcher. Yep, here is where I stop it. I stop it when I close the file. Yeah, there it is. It's just FW. Oh yeah, and I have to do it in a separate thread because you don't want to pause. So given that I'm using JRuby, not CRuby, I have support for multiple threads at the same time. I can run threads in parallel, which is not possible in CRuby unless you use the new feature, which is called Raptors. But fortunately in JRuby, I don't have to worry about that. And I personally love threads because I used to be a Java developer in the past, and Java has threads, and why not use them? So this is a good example of using them. I spin a separate thread to avoid pausing the IDE, which is pretty much fluid and fast. But in the background, they're basically demonitoring the file system for changes. Remember last open files? You guys already saw that in action when I opened Gladiator, opened all the last open files. That's just a matter of me, basically I have a load, let me see, was it a def load? Load config, ignore paths, load config. That's it, load config. I store a YAML file somewhere that contains all the tabs that are open. And when I close Gladiator and open it again, it just looks up the names of all the open files from that YAML file, and it opens up all those tabs. That's it.
Cheapest database ever.
Exactly. And finally, ignoring irrelevant paths. So if I have like logs, I don't want to open logs in Gladiator. Like logs are usually files that have 20,000 lines of code, or lines of data or more, like logs in a web application. So I have a bunch of directories that are ignored by Gladiator by default, and they're all over here. Yeah, like basically .git directory, I ignore it. Coverage, which gets data when you're running tests. Packages, node modules, nobody wants node modules. Temp, vendor, package, disk, log, test reports. So these are all directories that are basically ignored, and you can add more files to them. And basically, whenever you create a project, Gladiator will generate a .gladiator file that's hidden that maintains what are all the open tabs. This is the YAML file that I told you about. I'm showing you the content of it. These are the open tabs. I even maintained what the top pixel was, like how scrolled you were in the file, how many split panes do you have, what are the ignored paths, etc. So that's pretty much it. So I pretty much covered everything. What are some future features that are missing right now from Gladiator, which I haven't gotten into? The first one for sure is file content search. Right now I use grep for that. So yeah, file content search. There's a command on Linux or Mac called grep. You can use it to look up the contents of files. I use that for now, and it works pretty well for me for my workflow. But I'd love to in the future support doing file searches within Gladiator directly. That would save me a bit of time. Themes. Right now there is internal support for themes. I'm sorry about the misspelling here. But that is not exposed, so I can actually theme it. But I personally selected the theme that it has right now. Mark Andre recently asked me if it supports dark themes. I said no, but I can quickly support it if needed, so I'd like to support that in the future. Extensions, you can right now extend it. It's open source. You can just take the source code and extend it that way. But I'd like to make a more official way of extending it by providing a pattern for people to follow in order to build extensions. And maybe others could contribute that to the project. They could just build it and submit a pull request, and I'd be happy to accept it. And finally, better Windows and Linux support. I mean, I mostly use it on the Mac. On the Mac, I like it. I think it's very good for my needs, but on Windows and Linux, could use a bit of improvement. And that's about it. That takes us to the Q&A phase. So any questions and answers before we move on to something else, to announcements?
But just curious about how syntax highlighting works. Like,
oh yeah, let me get into that. Yes, I meant to get into that and I forgot. Thank you for asking. So syntax highlighting is part of the code text custom widget, which used to be part of Gladiator, but then I thought it was so useful that I extracted it from Gladiator and moved it to Glimmer. So now any user of Glimmer gets access to the syntax highlighting for free, for all the languages that I mentioned are supported. And by the way, the languages that are supported are mentioned here in the README. These C, C++, Crystal, CSS, JSX, JSP, JSON, JavaScript. Like pretty much all the things that you care about. SAS, CSS, SQL, etc. So this is the code text custom widget, which is not part of Glimmer. The key part about the key logic regarding syntax highlighting is me not doing the syntax highlighting myself. Basically what I did is I used a library called Rouge, which is a Ruby gem that has support for over 100 programming languages. So I'm exposing about over 30 languages that I care about in Gladiator, but the library itself supports 100 languages, even more than what I'm exposing. And Rouge does the support by, I'll show you how it does it. All you have to do is, there it is, online get style. This is a listener that will get triggered on every line you see on the screen in this widget before it gets rendered. So it's this screen that I'm scrolling right now, on every scroll or change, that method will get triggered. And it'll basically go and ask you to provide it with style for every character that is showing up here. So what I do is I use the Rouge gem by calling, I abstracted the whole Rouge gem thing using this method called syntax highlighting. So let's dig into what syntax highlighting does. There it is. It basically uses the Rouge lexer, and it lexes the text, meaning it breaks it into tokens. And for every token, it'll give me, so this is doing all the work. This is doing almost everything. For every token you see here, like this, for example, this line here is light blue, this is dark blue, this is red for the colons. Each one of those is a token. For every token, it gives me a foreground color, background color, font style, and everything I need to know in order to style it. So then I return this data as part of this method. I actually pass it to, I pass it to a block here. Oh yeah, I basically iterate over each token, and for every token, I grab the token index, the token text, the type, the foreground color, background color, bold, italic, etc. And I adapt all this data, that's kind of like the adapter pattern, into what SWT wants from me. SWT wants from me a style range object, and that represents a token. So then I give the style range object everything it needs over here, like foreground color, background color, size, etc. Font style as well. And I dump it into this thing, and then I pass this thing into the event object that comes to me from here. And when this block returns, the styling happens using the SWT style text widget. That's it. So this is all abstracted into a code text component, so you don't have to worry about it. Just give it the language. It just asks you for the language, and if you want the theme as well, so there is support for theming. And whether you want to see lines or not, this is what I showed you in this example. I can see lines if I want, or I can show highlighted code without lines. Oh no, this one does have lines, but without borders. This one doesn't have lines. Each one is a different theme. So, yeah, that's it. Any other questions?
Yeah, what was the most difficult thing or the thing you're most proud of in the project?
That's a good question.
I would definitely say syntax highlighting was one of the most worrisome things that I thought about at first, that I was worried it was going to be too difficult for me to implement. But like I said, my only other editor was Vim, and I was so tired of using Vim. So I hunkered down and implemented syntax highlighting successfully, and I was so happy when it worked the first time.
This may have just made JD very sad.
Here's the deal, man. Vim is like having a Chevy, okay, a Chevy Malibu. I'm trying to build a Mercedes. You may have a Chevy Malibu, modify it, add a whole bunch of cool features to it and extensions, but it's still a Chevy Malibu. It's not a Mercedes.
Extended, I understand.
I'm
where
using
it
the
comes
same
from.
technology as Eclipse, which is used for NASA. So that's like the Mercedes of building code editors. So that's what I'm trying to aim at, not Vim.
I have a question though.
Yeah, sure.
It's about Vim.
Oh yeah.
If you wanted to replicate Vim user experience, I mean like the hotkey combos and stuff like that, how confident do you think you could do that, like with your DSL and stuff like that?
No, you can implement anything with this DSL for sure.
Cool.
The reason I say you can implement everything is because even if there was a widget that didn't exist in SWT that you dreamed of somehow, like say a Vim editor, you can build your own widget from scratch if you want using custom canvas graphics. So it does have support for canvas graphics, meaning pixel by pixel. If you want, you can build your own widget. But in general, you probably want to avoid that unless really needed, because that's more work. But it's possible if needed.
Do you feel confident that with all the patterns you have right now, you could like get something close to what Vim has pretty fast, since like it seems like the abstractions are really good? Or do you think I would basically try to rewrite Vim in Ruby?
No, I'm pretty sure you could do it. I wouldn't do it myself because I don't like Vim, but I'm pretty sure you could do it. Any other questions? Okay, thank you everybody. Oh yeah, one more.
How would you go about, let's say I had an idea for a certain extension for Gladiator, how would you go about it? Like if I wanted to go to create it? Because I understand that I could create a fork, but I don't think it's really maybe very efficient to add features with forks for everything I would want to add. Maybe if there was a DSL for extensions, it would be a little easier.
Yeah, I mean you could get started by implementing support for software extensions. I'm sure a fork for that is useful. However, I mean to talk about a bit about that, I used to use in Java something called the Eclipse Rich Client Platform, which is the Eclipse itself is built on top of a framework, and I've used it to build desktop applications for business in a previous job. And the way we used it was we built extensions for the Eclipse. Not the IDE, the platform itself, the Eclipse platform, the Rich Client Platform. So things that they made extensible, for example, is when I open a tab, right now I support, say, 100 languages, programming languages. If somebody wants to add more support for something beyond Rouge, what the Rouge provides, which is, to be honest, it almost covers everything, but still, if you want to invent your own language and add support for it, I guess we'd have to open that up. So I'd have to modify the cotext widget to support passing a block that will do all the work that I just showed you about the lexer, how it lexes the words, the tokens, and then gives you coloring for them. So that's one thing. Another thing would be every part that you see here, like the file explorer, the file lookup, the navigation area, is a component. If we can also support the idea of people building their own components as extensions that can show up anywhere on the screen, that's something that Eclipse used to use and support with their framework. That would be cool to support with this in Ruby. So yeah, there are quite a few ideas on how to extend this. Also, you can extend menus, and you can extend the right-click menus, and you can extend preferences if needed. But if you ever think of building one of those features, please submit a pull request. I would appreciate it. Cool. Well, that concludes the Q&A phase. Let's get into the announcements. Thank you.
Thank you.
Everyone.
Thank you.